kind of making machines emulate the things people are good at. So machines are good at counting and playing chess, which people are bad at, but people are good at looking at stuff and writing Python code, which machines aren't very good at. So machine learning is what you use to make machines look at stuff, recognize what the stuff is, and write Python code. There are many techniques which the ML Meetup after us will tell you, and in general, like there's been a resurgence of neural networks and stuff like that that you can use for your super awesome code nowadays. But I'm just going to use Markov chains because they may not have the trendiness that generative networks have, but they're pretty cool, and you can just do your work with that as well. Although you can't get the pay raise with that, so if you're looking for that, just be careful. And as I said, I have to type this out. What are Markov chains? So Markov chains are basically strings of probabilities. So if you want to, for example, recognize some kind of text, you can create a Markov chain, which is basically you take a letter and then you say, okay, what's the probability that this letter will be followed by another letter? For example, you have a sentence, let's say, hello world, and we want to write a recognizer for this. We want to recognize if it's English, if the language is English, or whatever it is. So you take this and you look at the first letter, for example, H, and you say, okay, what's the probability that H will be followed by an E? You look at your text and you see that here the H is followed by an E, so you update the probability that that will happen. So you build a big table of transitions between letters. For example, if you have hello, the H is followed by an E. If you have hi, the H is followed by an I. So you add the probabilities that each will be followed by another letter, but you never, for example, follow an H with a Z in English. So that probability will be a 0. And you will know if you see something that has an H followed by a Z, you know that it's probably not English. So you can just take all of these and follow the probabilities. You can learn a model. You can basically write all these probabilities in a big table, and you can see that whenever you have these letters, you have an H, then it's probably going to be followed by an E or an A or an O, but never by a Z. And with that, you can just basically train your model to recognize valid words in the English language if you do it by letter. You don't have to do it by letter, though. You can do it also on the sentence level. Which means, just a second. So, for example, we can check that hello as a word, instead of a single letter, is followed by world. Or it could be hello, sir, or it could be whatever. So you learn all the things that might follow a hello in some text. You give it as input, basically say like all the words of the works of Shakespeare, and it will learn what each word was followed by in Shakespeare's works. And then after you do that, you can make another improvement where you don't just check one letter or one word. You can just check multiple words as well. So for example, if you have the two words good and morning, that's usually followed by the word that's. Or maybe it's followed by a word Vietnam, whatever. You teach your model all that stuff. If anybody has any questions, now's the time to raise your hands. You teach your model all that stuff, and then after you do all this, you can ask the model to generate some inputs from some outputs from what it learned. So you basically run it in reverse to generate the outputs. Any questions so far? It's been super clear. So let's write some code. All right, I'm going to use a library called the Markovify because I don't want to write all the math myself. You don't really need math to be a machine learning expert. You just need to know how to do import TensorFlow and import Keras and stuff like that. The math is just for the people who write those libraries. All you need to do is follow a few tutorials, and you're gonna be okay. We have a good one coming up in half an hour or so. There's a problem with this. Let me do that. 1, 2, okay. This is my new hit. Okay, import chain. Chain is the Markov chain that we're going to use to train the model first. So I've downloaded all of Django, basically the entire source code, and I concatenated it to one file. We're going to feed that file into this chain model, and we're going to ask it to learn whatever it can about the chain. But first, to do that, we need to convert the source code into a format that the model can learn from. Okay, let's read the code. I tried with all of Django, but it was too slow, so I just used 10,000 lines of it or something. And we read it into memory, and then we're gonna use regular expressions to split it. So now what we could do was we could split things at the letter level. So we can say, okay, learn what all these letters look like, but then it wouldn't really be a very valid Python. It would probably just be a jumble of just random letters. The variables wouldn't be the same. It wouldn't really look very good. But what we can do instead is split after and before words. So split on white space, commas, colons, stuff like that, which would give us a much better model for it. So let's try that. So as you can see, we're basically splitting on. Can you read this? Is this fine? Okay. So we're splitting in word boundaries, which means that words are going to be input to the model as they are, and then every other character will be input as a single character as well. And 3 means it should look 3 words back to figure out what the next word is going to be, which might be a bit long. 2 might be better, but it's fine. Okay, let's write a function to generate the code. So what we're doing is we're getting the chain to walk the model, and then this will give us some characters, words, things like that back, from which we want to basically join them into a string and then print them, or whatever, we'll do whatever we want since we have the function. Let's try some now. Let's print. We're gonna generate a bunch of code now and print it on the screen. So let's see what this looks like. Yeah, well, let's see. All right, so you can see that, this is reasonably like Python code, and especially it's reasonably like Django code as well. So this is like building a model. You can see that it doesn't really have the indentation down yet, because this is a bit more spaces than we need, but it's fine. For the spaces thing, we can do something else, because I don't know if this is an integer multiple of 4, which Python does need. So what we're going to do is going to go against pep8 and convert all the spaces to tabs before teaching the model. So we can just get our code and replace every 4 spaces with a tab. And since we've done this, we can just recreate the chain by teaching it. 3 again. So now we can just generate some more code and see how it looks. Okay, this looks much better. Well, not really very much better, but looks a bit better here. For example, I did create some functions which are reasonably named. It's trying to create an iter, but it didn't add the new line. So yeah, this looks better than before, but it really doesn't look like Python code yet, and I don't think it will run, for example. So you can't really claim that money yet. But what we're going to do, we can go from machine learning to full AI and write an adversarial generative model. So what that is Stavros, you can correct me if I'm mistaken, but basically what we're going to do is we're going to use something that can tell if our Python code is correct or is not correct. For example, in this case, we can use the Python interpreter or wherever. Basically, it will tell us if it's wrong, and if it's wrong, we can just go back to the drawing board and do another one until we get something that works, which is how machine learning works as well. We're going to use Black for this because Black has a server. Black is a code formatting tool that will check if your code is formatted correctly. It will format it if you don't have if you have spaces between your functions or if you don't leave the right number of new lines and things like that. Black can check and format it. But it can also tell you if your code is looking good, like if it looks like Python code, or if it doesn't. And that's what we're going to use. We're not going to use a formatting function of Black. We're just going to use the checking function. And since it has an API, I'm running the Black server on my computer now. Since it has an API, we can use that. So we're going to use Black in HTTP mode because it's faster. We import requests so we can do HTTP calls from that. And then we write a code validation function. Validate a piece of code for well-formatness. We just post basically the code to the local host with a port. And we have to encode it to UTF-8. Okay, and then we post it to the local host, and then Black will come back and it will give us the r.status code. Will be a 400 if it's wrong, or 200 if it's right. So, okay. Now we can check if some code is valid. So we some valid code here. Yep, it's valid. And then we can give it some invalid code. It should complain. Yeah, that code's not valid. So since now we have a way to tell which code is valid and which isn't, we can just try to generate a bunch of stuff, and Black will tell us what's right, and we can try it that way. Let's use time to see how long it takes. Let's run for 100,000 times, for example. Because that's how long it takes for machine learning stuff to generate one good thing. Let's have progress bar generate in seconds. Here we can generate some code. Oh shit, my indentation is wrong. Damn it. Ugh, okay, anyway. If the code is correct, we break. And it's generated. Okay. So, because the code is so kind of fucked up, it's going to take a while. If we had a GPU, we could have accelerated it. It would take exactly the same time because it doesn't run on the GPU, but we can't get funding if we don't do that. This is valid code that runs. This has never happened before. At home, this has never happened. But look, we managed, fucking hell. It managed to actually produce something that's actual valid Python code. Isn't this amazing? I'm so proud right now. Wow. Yeah, it's it's an import statement and a comment, but I don't know, I think we can raise $1 million from this. Yeah, thank you. Wait, look. I had this whole thing where I would do like this, in the usual case where it just doesn't run. But yeah, this worked. Amazing, Jesus. Wow. Anyway. Yeah, so now you can add AI expert to your CV. I do want to exit. And that's basically how you can write Python with Python through machine learning. You can see that it wasn't really that much code, right? It was just 5 lines, and we managed to create a fucking working Python program. It's amazing. Do you have any questions? How long did that take? Jesus. Okay. Nobody has any questions. Do you guys speak English? Actually, I never checked. Okay, good. If you got that. Yeah.
So there wasn't any improvement from the previous generation?
There was what? No, there was no. It's just like a random. Every generation you get a random new thing.
Not the generation.
No. So the adversary is basically adversarial, but we didn't have generative thing. Yes, exactly. Half the funding, just slash it in 500K. It's fine. Yes.
Yeah, I'm going to ask something. I'm not sure that it's a good idea, but could we train?
It's a great idea. I can tell you.
It might be.
Yeah.
Could we train the model after it produces something valid, so the next time it produces something other might be evaluating the
Yeah, so for Markov chains, you can't, because you already train it on valid input anyway, like you train it on actual valid files. So, you know, the things it generates won't be more valid than what you had, but for other kinds of models like, you know, neural networks and stuff like that, you can use that. You can train it with its own valid inputs if you know they're valid, to improve its accuracy. And especially if you can't really get much valid data, you can only get a few samples or whatever, you can use that. If you have a way to tell what's valid or not, you can use it to generate its own data, and then it will learn from that. So yeah, that's a good idea, but just in other kinds of models. Stavros, do you want to ask something? Because I see you there.
I enjoyed the next one.
Okay, I'm glad, thank you. Another question? Yeah. Of course I was typing there. I wasn't typing this exact thing, but I was typing, I was pressing buttons like, look. So no, because live demos suck, I use this tool that basically you just type whatever you want, and it comes out with your things. Yeah, because I mean, if it wasn't, you know, if I forgot something and it doesn't work 10 minutes, then it wouldn't be machine learning, would it? Who else? Yeah? It was the same Markov model. It just had black check the code to see if it actually ran. And by the way, the thing is, like, it actually ran and produced a real result that wasn't scripted, just the inputs were. So it kind of ruined the presentation because I had more stuff after it. But it worked, so what can I say, yeah. Any more questions? No? Okay. Yes?
Do we expect the market chain model to work better with larger input or smaller?
Well,
It's not like a network.
yeah, it generally works better with more input because it knows better what kinds of things to generate, but for this kind of thing, like a structured Python code, it won't really work well because, you know, you open a parenthesis, you have to close it, but our Markov network doesn't know it opened one, so it, you know, the only way it will close will be randomly, which is weird that the comment worked. Anyway. Other questions? Oh, you must have questions, come on, it's an amazing thing. Jesus Christ, you're a deaf crowd. Okay. So after me, we have the actual machine learning meetup, which probably not going to top this, but whatever, you can try. That's it. Thank you very much. You can subscribe on meetup.com/PyThess if you want to come to the meetup. And yeah, thank you.